Welcome to Get Your FRQ On. This question is from 2025. It's question 6, and it is not calculator active. In the question stem, we have a curve G defined by the equation y cubed minus y squared minus y plus 1/4 of x squared equals 0. In part A of this question, we are asked to verify that dy dx is negative x over 2 times the quantity 3y squared minus 2y minus 1. We use implicit differentiation here. The derivative of the equation y cubed minus y squared minus y plus 1/4 of x squared equals 0 is going to be 3y squared y prime minus 2y prime minus y prime plus 1/2 of x, and that will equal 0. Simplifying this, we get y prime times the quantity 3y squared minus 2y minus 1 plus 1/2 of x is equal to 0. And simplifying this, moving everything to one side, we get y prime of x equals negative x over 2 times the quantity 3y squared minus 2y minus 1 as required. In part B of this question, we are told of a point P on the curve G near the point 2, -1, where the x-coordinate of P is 1.6. We are asked to use the tangent line at the point 2, -1 to approximate the y-coordinate of this point P. So we evaluate dy dx at the ordered pair 2, -1. We get -2 over 2 times the quantity 3 plus 2 minus 1, which is -1/4. We use this to write the equation of the tangent line to G at the point 2, -1. This tangent line has equation y plus 1 equals -1/4 times the quantity x minus 2. Using this tangent line at the point where x is equal to 1.6, we get y plus 1 equals -0.25 times 1.6 minus 2. This implies that y is equal to -0.25 times -0.4 minus 1, which eventually leads to y equaling -0.9. In part C of this question, we restrict ourselves to points only with a positive x-coordinate and a positive y-coordinate. And there is a point S on G where the tangent line at S is vertical. Find the y-coordinate for this point S and show your work. So the tangent line to G at S will be vertical if dy dx is undefined. Dy dx will be undefined whenever 3y squared minus 2y minus 1 is equal to 0. Solving the equation 3y squared minus 2y minus 1 equals 0, we get y equals -1/3 and positive 1. However, since we are restricted to points only with a positive x-coordinate and a positive y-coordinate, the point S in question must have y-coordinate positive 1. In part D of this question, we have another curve defined by 2xy plus natural log of y equals 8, and there's another particle moving along this curve. When that particle is at the point 4, 1, dx dt is equal to 3, and we are asked to find the value of dy dt when this particle is at 4, 1. Differentiating 2xy plus natural log of y equals 8 implies that 2 times the quantity y dx dt plus x dy dt plus 1 over y dy dt is equal to 0. Simplifying this, we get 2y dx dt plus 2x dy dt plus 1 over y dy dt is equal to 0. If we substitute in the coordinates 4, 1, this reduces to 6 plus 8 dy dt plus 1 more dy dt is equal to 0. And simplifying this, we get 6 plus 9 dy dt is equal to 0, which implies that dy dt is negative 2/3. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.